Geometry, Faculty of Mathematics of BK Birla Center for Education, Pune. I am going to discuss about the chapter matrices today. And there will be a small module of an introduction of matrices, where if there are about finite number of elements chosen, and how are we going to arrange them in the form of rows and columns. In this chapter matrices, it mainly speaks about how do we arrange all the entries selected in the form of some rows and some columns. Say, we call A11 as an entry, A12 as an entry, and A1n as entries of the first row. A12, A22 and up to A2n forms the second row entries, and it goes on further. The mth row entries are denoted by AM1, AM2, AM1, where here there are m rows of entries and n columns of entries. We say the horizontal entries are called row 1, row 2, row 3 up to mth row, and the vertical ones are called column 1, column 2 and nth column. Such a way of arrangement of all elements or all entries or wherever we have derived the data from the other resources, the solution of a big polynomial. This arrangement is called a matrix. If there are several matrices involved in finding the solution of a specific task, we call them as matrices. The plural form is matrices. In this chosen sample, there are m rows of entries, R1, R2, R3, R2, Rm. Column 1, column 2, column 3 up to column n. Therefore, we call there are m rows and n columns. By the way, the order is defined to be m by n as order. Or the total number of entries will be m into n. Total number of entries or elements we say is m into n. If we have 12 elements, if there are 12 elements, now we can have an analogy of identifying how many possible ways of arranging them into different matrices. Say, number 1, we can arrange one row and all the 12 elements are defined, 2 rows and 6 columns, 3 rows and 4 columns, 4 by 3, 6 by 2 and 12 by 1. So such a way of arrangement of the same set of elements into different matrices are possible, where these are all possible forms of arranging them. So initially we had taken only 12 elements. There are 12 simultaneously satisfying concept of elements of a specific task chosen, where 1 by 12 indicates there is only one row, so it is also called under the types of matrices, it's called a row matrix. And the last one, if we take up, there are 12 and there is only one column, it is called a column matrix. The rest of the orders, these are all the different forms of making matrices, where the number of rows is not equal to number of columns. These are in general taken to be rectangular matrices, as this is the difference of length and breadth. One dimension, or maybe the row is different from the column is different from the row. By the way, these are explained to be rectangular matrices. We can especially say both the cases, the number of rows and number of columns are bigger. Say m by n. That means we have 3 entries in the row. For instance, we are taking these elements. There are 3 rows only. And there are 3 columns. In this, the number of rows and number of columns are equal, which indicates the matrix is of type square matrix. We call this as a square matrix. Now we have seen so far how we are able to represent the set of all elements satisfying a specific task chosen into a matrix form. And these further, they are developed further into the representation of matrix in different types. The first step we can say there is only one row involved, it's a row matrix. There is only one column involved, there is a column matrix. These matrices where the number of rows and number of columns are different, it is called a rectangular matrix. Where the number of rows and number of columns being equal, it's called a square matrix. Further, let me take G as a set containing elements -1, 1, I and minus I. These are the four elements which satisfy the equation x power 4 minus 1 is equal to x power 4 is equal to minus 1. We call this as the fourth roots of unity. This is also called fourth roots of unity. So when we find the fourth roots of unity, we get x square minus 1 into x square plus 1 is equal to 0 as the factors of the initial form. This gives us x is equal to, say, plus 1 and minus 1, and this when we solve it gives us I and minus I. So if these four elements are considered, frame a matrix in the form 1 minus 1 I minus I as a first entry, and the operational feature of, say, star or addition, we are going to change the entries, and those entries could be written in the form, say, minus 1 I minus I plus 1, I minus I minus 1 plus 1, or minus I minus 1 1 plus I. All these orders are generated from the operations on the entries of this particular solution. The solution of this equation having the fourth power, it gave us about 4 results, and out of those 4 results with the operational feature we are able to form a matrix. So there are many complex calculations which we will be able to solve with the help of matrices. Anyhow, this introduction might help you. In the next module we will discuss about further how all the types of matrices are concerned. Thank you.